This is the pop can crushing lab, which goes with Lesson 30 in your Friendly Chemistry course. In Lesson 30, you'll have introduced your students to the idea of Charles' law. Charles' law is the relationship between the temperature of a gas and its volume. In this lab, we will take a heated gas inside a pop can and then quickly change its temperature and watch what happens. Equipment you'll need for this lab includes a supply of clean aluminum pop cans, a heat source. We'll be using candles here. If you use candles, we found that if you use more than one, your results are better. A better heat source is a Bunsen burner, or even a hot plate or cook stove works just fine. You'll also need a container which can hold cold water, and the colder the water you can get, the better. So if you want to add ice cubes or crushed ice to your water, that will improve your results for this lab. You'll also need a set of tongs and then some water that we'll add to the pop can. So to begin the lab, what we'll do first is light our candles. You can discuss endo and exothermic reactions again as you light your candles. Got our candles lit now. Douse our match. And then into your pop can, we want to add just a small amount of water, like a tablespoon or so of water. So I'm just going to pour in just a little bit of water here. Okay, and I'll slosh it around so you can hear. Just a tiny bit of water in the bottom. What we want to do is bring that water to a boil so we have a hot gas, the steam, inside our can. So what we'll do next is take our tongs and we'll go over to the candles and begin heating the water inside. Now you want to be careful, make sure you've got your tongs gripped well on your can so the can doesn't move away quickly. So we're just going to start heating the water inside the can here. And once we see steam coming from the top of the can, that'll give us an indication that we're ready to go with the next step. I think you can hear now the water's beginning to boil. We're seeing little wisps of steam come from the top of the can. We'll just let it get going as fast to boil as it can. The next step involves us taking the can still in the tongs and quickly inverting it into our cold water here. Now when we do that, we want to make sure that as we flip the can over that we don't allow any of the water to spray out and get on anyone. So if there's any student sitting over to the side, you'll want to make sure that they've moved away from your table here. So it sounds like we're getting a pretty good boil here. Now this is a one-time shot kind of deal, and so once we do it here, hopefully we'll get good results. If not, we'll have to go to another can. So we've got steam coming out the top of our can here, and we're about to give it a go here. Like I said, the colder your water here, the better your chances are for good results. Alright, we're going to go ahead and give it a try and see what happens here. So I'm going to carefully take, and we're going to flip it into the cold water here. I think we're going good now. Let's give it a try. 1, 2, ready, go. Okay. Now, that's not terrible results there. I've seen where the can just totally smashes to nothing and it might just even totally collapse. Top goes clear down to the bottom. And so this is fair results for this lab. I think you could probably do better. So I think you can see that this can could be used again, but you'll probably want to have a fresh can and start the process again. You might talk with your students also, what is the black on the bottom of the can? And some may recall back to your first lab you did with the marshmallow that this is indeed carbon, and this is some carbon compound that's collected here on the bottom of the can in the soot. The candles that are burning over here actually are evaporating the wax. The wax melts, and then as it gets hot enough near the flame, it evaporates, and that's what's actually causing the burning, allows the combustion or burning to continue, is that evaporated wax catching fire and then burning. Now, as that wax evaporates, not all of it combusts, and so when it reaches the metal or cool surface here again, it will collect, and so that's where the soot is, and it will get on your fingers and hands and clothing, so you might just be aware of that as you conduct this lab. So this is the pop can crushing lab, which goes with lesson 30 in your course, which is a demonstration of Charles' Law. Enjoy your time with your students.